on the fly. But other than that, that's it really. Yeah, that's it for me.
You're more happy now with using Three Musketeers for infrastructure?
Yeah, definitely. Yeah, really cool, really cool.
Just ask someone else to continue.
AG?
So I've been working on the project as well. I've done just 2 exercises that I did before, but there was some requests, and I tried to figure it out those. Yeah, that's it. So we are really happy that we could see at least the application running on our browser. And yeah, so we need just to make sure if the DB is working and all the tasks and service also, and that's it. Let me see, Denise.
Just picking people from our group, eh? Hi everyone. So yeah, the last 2 weeks also focusing on the project, fixing a few issues. My case especially about parameter store. Very exciting that the group is working and on our code, so now it's closer to be working the way we wanted. And I will mention that, at least for me, it would have been ideal to have done until exercise, until the end of the class 5, because I'm trying to learn as I do the project. And then I go back and start reading one exercise or do one of the exercise class 4 or 5, and then, it gets more clear. So I know the intention was to do the exercise before the project. It didn't happen for me, but now I see it would have made a difference. Yeah, let's see what happens in the next 2 weeks. So should pick someone. Who is there? I'll go Lucas.
Oh, hi everyone. Yeah, this last 2 weeks I've been working on the exercise as well, and we were trying to meet with our group to establish some tasks to finish the project. Our group did a lot of things like before the presentation, so we're basically just fixing some requirements of the project. So I think it's been good. And I'll choose Anderson.
Hey, so the last 2 weeks I've been working on some exercises, and just to understand way more about the modules before I jump again on the project. We haven't done much work on the project. I've been busy with my new job as well, so yeah, so I'm just focusing on the exercise right now, but we have to go back to this project again. Yeah, that's it for me. Let's see who next. Heaven.
Yeah, so we've been working on the exercise, so managed to finish. I think I created a PR for there's only one exercise left, which is the GitHub Actions tool. So basically, spent most of the time implementing the 3 musketeers pattern and trying to understand that better, and also did a bit of a look of the Docker, because I think when we implement something, always get stuck in the Dockers, for example, missing something in like volume mapping, port mapping, and haven't do much on the project yet. Thinking to do it like in the next 2 weeks to finalize everything with the team. Yep. Karina?
Yeah, so for me, being very honest, the past 2 weeks I didn't do much. I was very busy with my work. I had to run a few trainings for the team, so I had to prepare everything, and I was just quite tired. I couldn't do much on this course. But yeah, for my plans, I will do the exercise for class 5 and within this week. This weekend, sorry, and then work on the project as well to review what is pending for us to finalize the project. Let me see who has gone yet. Christina.
Hi everyone.
Hey.
So thank you. So last 2 weeks, I've been we've been trying to finalize some priorities for our project. Still going, and trying to catch up on my exercises as well, and GitHub Actions. Yeah, and I've been also busy with my work. Next one would be Luis.
Hi guys. Over the last 2 weeks, I haven't done much in the project. I did a few exercises, and yesterday I completed the CI/CD pipeline of our project. It's still pending review, but yep. As Lucas said, the last presentation, we already have done lots of things. So I hope you can close everything over the next 2 weeks. Okay, who is next? Marcio Naturello.
Hey everyone. Okay, the last few days we review our project, and we have been check about some requirement which we not delivered the first presentation. We update that task and review to distribute those to everybody. And our plan is take this done for the next 2 weeks and see which improvement we can deploy on that. That's it.
I think you are the last one.
I guess, yes. Yep.
Anyway, just bear in mind, the project deadline is not this Sunday, the next one is not until Tuesday. So on Sunday night, 12 o'clock, we are gonna remove your access from your project repositories, and that's it. So then we can have time to have a look on what you guys have worked on, and it starts to provide better feedback on the last class. I'll pass to Dennis and Kiko, which will be doing the class for today.
Nice, thank you, Caio. Good evening, guys. Are we all here?
See Marcio.
I can see Marcio.
Marcio Faria.
Faria,
yeah, but we gotta move on.
Okay.
It's a lot of thinking for a single class, so.
Okay, so
he's here. Then if he
yeah, please.
Yeah,
maybe send him a message in private. So that's all right. Let's get started with class 7, and let's see what we're going to learn today. Let me share my screen. Yeah. Okay. It's called class 6, but it's half class 6 and class 7. So what we are going to see today, we're going to talk about serverless as the concept, and we are going to go through some tools and services that AWS offers to us in the serverless space, mainly API Gateway, Lambda, DynamoDB, KMS, and SSM, the parameter store. Probably these 2 last services you already used for the first project and you're more familiar with. Those other 3, API Gateway, Lambda, and DynamoDB, are services that are used frequently, I'd say, in the enterprise, because it's the main way of doing a cheap and scalable integration to expose some business service. So the API gateway is going to work as the main integration to reach out our system. Lambda is going to be responsible for the computing and processing of the business logic, and DynamoDB as the data store for it. So let's get started with serverless first. So what's serverless? It's basically a way of doing computing without worrying too much about managing servers. It's about the shared responsibility model that the cloud providers as AWS offers, and who is responsible for what, right? You might have noticed in the project one that some people used Fargate as the computing service, and other teams used EC2. Well, the difference there is that those teams that are running in EC2, they need to manage those services, and they even need to run some scripts to join the ECS cluster and so on. While the team using Fargate, which is a serverless service in AWS, they just cared about setting up some memory, saying how much CPU they need, and everything else is AWS responsibility. So they don't need to manage the server behind it. So serverless doesn't mean that there are no servers, but in fact, it's about who is managing that server, right? Usually, a serverless service is associated with high availability, scalability, and fault tolerance. So you don't need to care much about an AZ that went down, data center that was on fire or something like that, because usually you pay for some cloud provider to manage it for you, and they have SLAs for these contracts, right? So what you find in a serverless architecture, just an example of a very simple one that we are going to touch in our exercises, and we are going to see some services for. So you could do some architecture like this one. Let's suppose you have a user that goes into a web form, fills it, and click in the submit order. When he does that, it's going to do a request that will hit an API gateway that will say, who is requesting this action? Okay, it will grab some credentials from this request and do the authentication for this request. The next thing is for this action, which backend is responsible for processing this? So in this case, it's a collect payment function. And this function could run in Lambda, for example. And finally, this function will interact with some kind of data store. I'm showing this specific architecture here because it's very common. You'll find it, probably you've worked with this kind of integration. But what changes, what we are going to see today, it's how to do it using the serverless services. Because you can, well, do this architecture, implement this architecture using other services, right? You can have an EC2 here running an API gateway product that will dispatch this request to another EC2 maybe, or to ECS running on EC2 and just do the business logic. we're going to see services to do it in serverless, right? So serverless is focused on the agility. Agility is how much effort is needed to be put in order to have actual business value, right? So if we are going up in that responsibility model layers, right now you don't need to manage the servers anymore. So you don't need to worry about infra network. You don't need to worry about patching instances. You don't need to worry about, well, high availability up to a certain level. So you're paying for this while you're focusing on the business function or the business value, right? Which is the actual code you write in Python, Node.js, or any other language.
Dennis, sorry to interrupt you, but I'm not able to move Marcio from the attended list.
Okay.
Sorry.
Where is it? Marcio. Done. Yeah. Okay. Okay, so what are examples of serverless services in the AWS cloud provider? For computing, as I mentioned, we have Lambda, Lambda at Edge, and Fargate. Storage, you have the simple storage service, which is S3, you're familiar with, object storage, and EFS, which some of you have used for Project One, so scalable file system service. Data stores, DynamoDB, we're going to see it today. Aurora Serverless, not the regular Aurora that you used for, some of you used for setting up Project One, but the serverless one because it can scale infinitely, and you can just ask how many units of processing you need. And it scales to 0 as well. So if no one is using that service, you don't need to pay for it. And from this note, I'd like to say that many serverless services will have this characteristic to scale to 0, like Lambda. You just pay while it's running. So you pay in batches of milliseconds usually. For Lambda, 100 milliseconds in 100 milliseconds. When it's not being executed, usually you don't need to pay for it. So your operational cost is also low. So that's another benefit. You spend less to build it, you get the business value, and when you're not using it, it can just scale to 0, and that's all right. You can go on. It's very good for startups that need to get going with some investment, get some value. And if it scales in a way that it's out of control, like you're hitting the AWS limits, for example, and you need a different solution, then you can re-architect your solution to use a cluster of EC2s or anything else you need, right? Well, RDS proxy and API proxy, we have the API gateway service we are going to see today. Well, so the benefits, just as the takeaway for the intro of serverless, no servers to manage. It's flexible in terms of scaling and high availability. And usually it scales to 0 with no costs when nobody's using it. When it doesn't bring value, you don't pay for it, basically. The overall processing model is something like this. you have some events coming. Some controller, usually from the AWS side, will handle these events and will dispatch this to a computing backend to do the function and return the response. And that's all. That was a request. This is not just for Lambda. We can say, for example, for DynamoDB, when you request to insert an item, you dispatch this request, AWS controller will get it, will do authentication and other cross-cut concerns, and call the core of the DynamoDB service to actually do the operation and return a response to you. So it's this very same processing model for almost any service in the serverless space. And I included some links here for some very good trainings. I really recommend doing that if you're interested in serverless, architecting serverless solutions. And these ones are from AWS training websites. Yeah, all of them. And they are free. So you can go in your own pace and just do it. I really recommend it. So let's jump into the for service API gateway. So what's an API gateway? Have anyone used an API gateway here? Or can someone explain to me what's an API gateway?
I tried to play with once, but my model was bigger to host it on AWS Lambda.
Lambda. Did you use API gateway for that?
Yes, because the plan was create an API, the model like put on marked.
Okay. Yeah, as I said, and it's a very important point, Adriana, you brought. These services, now you're paying, right, AWS to take care of many things for you, like scalability and high availability. But these services do have limits. And it's an important thing to bear in mind because you think you're never going to reach those limits until you reach it. And you need to think about something else, or you need to apply a workaround or re-architect your application to work properly. And it might be because there was a lack of architecting in the beginning or something like that, because it's so easy to get going that sometimes we forget about the limits. So yeah, I remember you said you hit the 250 megabytes in the Lambda. We're going to talk about this in the Lambda section. So an API gateway is a pattern. It's an integration pattern, in fact. It's a way of exposing an interface in a way that other services or clients can reach a backend service or any other service. So it just sits in the middle. It has some responsibilities like authentication, throttling, when you have too many requests that you need to hold some back because you cannot handle all of them. It can have, well, DDoS protection on your endpoint. Well, yeah, you can have usage blames, like saying a customer can only do 100 calls per month, but another customer can do 1,000 calls per month. But it's not intended to have business logic. So a bad pattern and not untyped pattern would be having too many, or in fact, it's good to avoid any business logic in the API gateway, because it's just orchestrating the requests and doing these things like authentication. It's not supposed to have state, like holding sessions or storing data, or applying business logic. It just routes to the correct service. That's the main responsibility. Usually we expose an API gateway via the HTTP protocol. Let me see if I have a, well, I don't have an image for exactly that, but I'll jump to this image, which are the types of API gateway we have in AWS. Usually when you work for a company and product owners comes and says, now we need to start to store customer information. We need to store a name, a first name, a last name, and an email of the customer. Probably the way the team is going to implement it, and that's a standard we see in several projects, it's going to be in HTTP API exposed in some API gateway, hitting a backend that will actually store the information. So HTTP is the main protocol we see when working with API gateways. But here you'll have another option in AWS, which is WebSocket. So if you're doing a chat application, like the client goes there, open a pop-up and can start typing, and some another person, an agent, can just reply back, and these messages keep flowing around. Sometimes you don't want to make a HTTP request for every message that comes and goes. There's too much overhead. You need to set up the HTTP request, dispatch it. There's encryption in the way. So you need to decrypt and encrypt every time you send a message. Too much overhead. If your volume is high, it's even worse. So in this case, usually WebSocket is used. Usually you authenticate once and open a full duplex communication, which is a communication both ways. And this connection keeps opened while data is sent from any side, right? So AWS also supports this kind of API. And you can see here in the bottom, you can see the REST APIs. The REST API is an HTTP API in AWS, but it's an older version of the HTTP API gateway in AWS, and it has more options if you need to manage things like usage plan, for example, as I mentioned. You won't find this in the HTTP API type, but you do find it in the REST API. And the price difference is about 30% cheaper for HTTP API, I think. So here you have less options for HTTP API, but you pay less. REST API, more options, you pay a little bit more. And the REST API can be private as well, which is basically, instead of creating an endpoint publicly that anybody can reach, I want to create an API just within my VPC. So just services inside that VPC and subnets can reach my API. That's another option. So when you create a new API, what usually you need to define? Can someone give me an example of HTTP API endpoint? It can be anything.
I
You mean
came
the-
across.
Yeah, you mean
Sorry.
just that the push and requests, the put and requests, and we need to receive datas and send datas.
Yeah, but what's the format of API endpoint?
Right,
When
this is the entrances, that how the data is gonna be received, right? Like, for example, if you're asking the name, the user's name, you need to have a text box to insert it then.
Yeah, that's correct.
All right.
That's one of the things which are part of a request, which is the payload, which is the actual content we are sending to the server to be processed, and a response will come back with some more content probably. But the format of the endpoint of an HTTP API usually is composed by these things here. So first thing is a resource, which is a path, right? So you might have anything here, anything that makes sense to your business domain. There are practices, there are papers about RESTful APIs and how to model them correctly, right? I'm not saying you can just put anything here. But it's simple as saying, I want a resource called /accounts/some ID, which is the ID of that account. So as this is a hierarchy, what's under account, it's related to the parent, which is account, right? So this is an account ID. I may have another resource called /pets. To talk about pets, if I want to create pets, list pets, update pets information, it's just /pets. So what's going to differentiate if I'm creating, listing, reading, or deleting something?
And establish some actions. So like Adriana said, like push or get or delete.
Not put, you mean, right? Mm-hmm.
I think in the request, you need to specify, is this a get request, post request, or put request, or delete request?
Yeah, that's correct. So you could use any HTTP method to define any API, but there's a convention, and that's a right way of modeling RESTful APIs. And there's a meaning for each one of these methods here. So we usually use HTTP methods as delete, get, put, post, patch to act on these resources. So as an example, post requests usually are for creation of resources. So if I do a post /pets, I'm creating a pet. I'm not updating, I'm not deleting, I'm not listing, I'm creating. Put for update in the whole object. So if I do a put pets, I'm updating some information about my pet. Delete for deletion, and so on. There are some discussions about modeling, but it's not part of this course. I'm happy to discuss with you later if you have any question. Patch, for example, is for partial updates. So for updating just the name of my pet, for example, not the whole pet. So we have the resources and we have the methods, which are the actions, right? And now we need something to process it. So a request came here, I could identify it, I could do a match. Now I need to route it correctly. So what are the options we have in AWS for API Gateway? If you're doing an HTTP API, you can integrate with Lambdas or HTTP backends. So you can route to Google if you want to, for example. While this, let me open this this console. For WebSockets, you can call as backends Lambdas, HTTP, or AWS services. We are going to talk about these AWS services in a minute. For REST APIs, Lambda, HTTP, AWS services, and mock. Do you know what mock is?
It's a service that you can create, like most of schools and colleges in uni used to use this system to create their website, or am I wrong?
No, I think it's another concept.
MOOC, yeah. Okay, forget it. Never mind.
Yeah. Anyone else? What's a mock in terms of testing? In the context of testing.
Would that be a mockup, just a template or something related to that, to do the testing?
Yes, exactly. A simpler response would be, it's a fixed response. You can, of course, assert behavior and other stuff in the context of testing. But here in AWS is the possibility of returning a fixed response. So if I want to hard code, I return 200, which is a success in HTTP, and some fixed body, I can easily. And this is important because we can enable other team members in your team to keep working while the API is not even finished. So you say, for example, for the UI guys, they are developing the front end, right? You agree they're going to call get pets to list all of your pets, but you haven't developed yet your Lambda. What you can do is create a mock, for example, just for them to hit this API and actually finish their integration part with the backend while you're still working in the Lambda or the backend, right? So that's it. These are the types of integration we have for API Gateway. And finally, you need to deploy this API in order to generate endpoint. The endpoint will be, in this case, for HTTP APIs. It will be HTTP colon / something, some host, and your API resources. So in order to deploy it, to generate this API endpoint, you need a stage, and you need to deploy to this stage. So let me show you via console quickly how we can create an API in like 2 minutes. So this is the API Gateway service, right? If you come here to create API, you're gonna see that those 4 options. I'm going to create a REST API. You give it a name. You can specify here if it's private or not. You can import Swagger or OpenAPI 3 definitions, which are basically JSON files with certain attributes. To be simpler, I'm going to use an example API. So it's bringing here an example of resources and methods. It's easy to read. You can see in the / resource, we have a get method that will respond me with 200 successful operation. If we scroll down, you're going to see that it has an integration that returns some stuff. You're going to see we have a resource /pet, which has a get method. There are some parameters in the input, the types of response and integration it expects to have. This is part of the Swagger definition. Well, I just imported this API. Here you have the resources to be defined, right? So I can easily come here and say, let's create a new resource. Let's call it DevOps. So it's going to be /DevOps. And just under it, we say what we are going to do with /DevOps. Let's say we are doing a get, for example. So I want to fetch something. I want to list something. When I do that, I have these nice options to say which type of integration I want to do. So I'm going to send this request to a Lambda, to an HTTP, to a mock, another AWS service. And this one, I didn't talk about it yet, but basically you can redirect this request to any of these services here. So for example, you could say, I want this request to be mapped directly to DynamoDB. Of course, this request will need to have a specific format, which is the contract that DynamoDB understands. But basically, you're doing a proxy. API Gateway is working as a proxy for a request to hit DynamoDB. It's just doing authentication and some other stuff, but your backend in this case is DynamoDB directly. Well, for this example, I leave it as HTTP. For HTTP, you can include here any endpoint you want. I'll hit google.com. Save it. Okay, so now for deploying this API, what do I need? What do I need to deploy this API and actually get an API endpoint?
To a storage, so you can to a data. Or
your website or where you're gonna host?
No, almost. What didn't we do that we mentioned as the main building blocks? Did we specify a resource? Yeah. A method? Yes. Integration? Yes.
State.
So you basically need a function or stage?
Yeah, we need a stage. I don't need a function here, a Lambda function, because I'm integrating with HTTP, not a Lambda. So I'm just going to check my stages, if there are some. No. So I'm hitting here, stage creation. I'm calling it dev. Oops. Apparently I can't create it directly. It depends on a deployment first time. There are some moving blocks in this REST API, the old one, not the new one. You're going to see it in the Terraform exercises. So I'm creating a new deployment. And by doing that, I'm also saying, please create a new stage for me called dev. And I'm hitting deploy. So that's it. It's deployed. And it created this endpoint for me. So if I copy this, go to my browser, what was our resource? DevOps, right? The method is get. So that's why I'm just using the browser here for simplicity. But if it was post or another verb, you can use curl, for example, to do your tests. That's it. This is google.com. It's a strange response, but as you can see, yeah, believe me, it's google.com. Yeah, it's here. So yeah, that's a way of doing a simple creating a new endpoint in the API gateway, hitting HTTP service or endpoint, right? You can do it in a similar way with Lambdas or any other AWS service. You just need to read the docs first about that service. It's not that straightforward, right? Because the services expect some input from your side to do the actual integration. So that's it. The rest of the steps, defining a resource, a method, managing stages, it's pretty similar. And you can define, let me touch on this. I think that's the last topic for the API gateway. So we talked about this, integrations, right? Security. So what are the options when it comes to securing your API? Let's suppose it's a public API. It's an endpoint like this one. You can hit it from your machine right now. You can also create a private API. But in the case of the public one, you want to secure it. You want to authenticate who is calling it. So the options you have are basically these three for authorization. You can use an AWS service called Cognito to authenticate users. So in this Cognito, basically you have a user pool. It's like a user database. You can specify name, email, telephone number. You can do email verification, SMS verification. It manages users for you. And you can use this user pool as the actual users authenticated, enabled to access your API endpoint. So you connect to these two services. You can write a Lambda authorizer, which is a custom Lambda. So you say, when a request comes, please call my Lambda authorizer. And in this authorizer, you can do anything you want. You can check in DynamoDB, you can check in S3, you can check in any data source that you have. And then you return a response saying it's authenticated or it's not authenticated, and which role this user has. So it needs to map to a set of permissions, the same permissions that you saw in the IAM service. And finally, you can use IAM permissions to authenticate users. These IAM permissions, in this case, you'll need to use a process called SIG-v4 signing, which is a process that basically will get some credentials, get your request, the verb, and some other stuff. It will hash the thing, get the bytes of it. It will do 7, 8 steps to produce a token. And this token is the key for signing that request. You can find more details about the SIG-v4 authentication. Here you can find the detailed steps, right? But basically, this process is what happens when you use AWS CLI. It's signing every API request it does on your behalf using the SIG-v4 signing process. If you're going to do it manually, of course, you need to implement those steps in Python or any programming language. And finally, API keys, which is one of the simplest methods for authenticating. It's not so much about authorization, because with API keys, the requester is going to send a key, which is basically a hash string. And the API gateway in AWS will try to match it to a known list of API keys. If it matches and it has quota enough, it doesn't exceed any limit that you put there, then it can go on and do the request. So an API key will be something like this. You need to create usage plan here. In the usage plan, you have your API keys. You can add API keys per client if you want to. No, it's referencing non-API keys. But in the end, it will be something like this. I'll delete this one. But it's just a hash that you pass in your requests in the header usually. So you have something like this. X API key, then you pass the API key and call your endpoint. If you don't call your endpoint with an API key, you receive an error 401, unauthorized. And yeah, that's it. And here in the resources, you can point out which resources need API keys. So do you see here? API key not required. If I want to change that, I can come here to method request, which is the first step of this integration flow, right? And say API key is required. And that's all. So with API keys, you basically are controlling if the user is authenticated or not. It's not much about what he can do or which endpoint he can call, but if an API key was declared or not in the request. There are some other features. Well, for the services, as you notice, we are not covering sorry, all aspects of every service. There are a bunch of documentation and other features to be used, like catching in the API gateway level. You can do OAuth 2.0, data encryption, and so on. So feel free to read through it if you have any questions about this. let us know. There's a nice chart in this link here that compares HTTP API and REST APIs just in terms of functionality and features, when to use either of these two, because they are so similar, right? Is it worth it to save a little bit of money, but then I'll need to rework my solution in the future? So this chart here might help you in this decision. And there's a tutorial, a full tutorial here on how to integrate a REST API with a Lambda proxy integration. Okay, any questions here about API gateway? No? Okay, let's move on to the next subject and talk about Lambdas. So API gateway can integrate with Lambdas, which is a very nice integration. And what are Lambdas? There's I'd say it's like a category of computing that's called function as a service, and that's where Lambda fits. So with Lambda, you can execute functions just caring about the content of that function, of the business problem you're trying to solve, and not caring about the underlying infra availability and other stuff. So with Lambda, basically you define some business code, and Lambda do support several languages. As an example, let me see if I have a list here. I can quickly show you. Just type Lambda in the console. You can create a function from scratch, blueprints. But what I'm going to show you is what are the runtimes available to you if you're doing function as a service in AWS. So you can do your business logic in any of these languages and frameworks, or you can define your own bootstrap. Well, I've worked with Node.js and Python. Usually there are some benchmark posts and blogs that compares these languages in terms of efficiency to run. They're fairly similar. Java was not that good. Neither was .NET in the past, but with .NET Core, a lot of things changed. Now .NET Core is one of the fastest code starts that we have in Lambda. So before talking about code starts, how do I set up a Lambda? How does that work, right? Think about that processing model I showed in the serverless intro, and see the event sources here. So Lambda works this way. An event will come from any source. It can be API gateway, as you saw, but it can be, well, several sources. You can even invoke a Lambda from your AWS CLI directly. So an event will come. the Lambda controller, you remember that controller that we had on the AWS side? It will get this request and analyze if there is a existing container running for the Lambda. Because behind the scenes, Lambdas are just containers. It's using the micro VM, I think. They changed the framework. I don't remember, but it's a container running. So what the event processor controller will do is check if there are any containers available to run that function. If there is not, it's going to spin up a new container and call the entry point of your function. So when you create a Lambda, you need to define what's the main method that's going to be called. Then your business logic will run. You're going to do what you need to do for the business. And it's going to return some information. So the processor will get this response and route it back to the requester in this case, right? So event came, you processed and returned. That's it. Lambda can interact with other services as it runs. In this example here, you can see we have Kinesis, which is a streaming service in AWS. There's a new record here that's triggering a Lambda. Lambda, while running, is calling DynamoDB to do some stuff, and Lambda is returning back a successful response or an error, right? So the cold start that I mentioned before is nothing more than the controller checking if there's a container available and not finding an available container to process that Lambda. So the cold start is the event of spinning up a new container to run that Lambda. And cold starts are important because you're going to notice a higher processing time in these Lambdas executions because AWS needs to bootstrap the Lambda on this new container. And this new container will be alive for some minutes, between 5 to 6 minutes, and it can handle more requests than one, right? So a cold start happened here. There's a new container, executed the first Lambda request. You may have other invocations here during a period of time that we don't have control on. And after 5-6 minutes, this container will die. And the new request that comes after that will spin up a new container again, and you have a new cold start, right? So be aware of this particularity if you need, well, it depends on the application, right? If this latency gets in the way of your business value, for example, it always processes in 100 milliseconds. It always processes in 10 milliseconds. And I cannot afford, let's say, 500 milliseconds for cold starts. Then you need to apply some solutions for cold starts. We can talk about that later. But basically, you need to keep your container hot for it not to die. And if it dies, this process that you have will spin up a new container before a business request comes. We can talk about cold starts if it's a problem. But just
I've got a question.
You know. Yeah.
With the code start, so as the container is being built, is the container being built exactly the same time across the board, regardless of the language you're using? And it's just the wait time is the language of executing the particular code. For example, as opposed to Node.js and Python, the speed difference is the execution of the function, not the container build.
Now, in this case, cold starts are related to the bootstrap of the environment itself. It's not, well, it's not, this is a tricky one. It might be related to the language, right? Because for bootstrapping different runtimes, you might need different files, right? For bootstrapping a Java, probably you need a bunch of jars, which has a size X. For bootstrapping a Python runtime, you need other py files with a size Y. So the language might impact the cold start here.
Okay.
But
cool.
it's not only about the time that your business function executes, but before that, it's bringing up the environment and setting up the the environment for your function to run, basically.
Yeah. Cool.
We got a question, so
yeah.
How is the process path? I mean, so first of all, the data is gonna be saved on the database, and then the AWS Lambda will be triggered. Or before they save your data, they will pass through AWS Lambda.
So in this case, Lambda is not saving any data. The only thing that comes to it is the invocation request that might or might not have some payload. So this data is temporary, right? It's just request time. It comes, it invokes the Lambda, then inside Lambda, you can store data, you can do whatever you need, and respond back with a temporary payload again. But there's no state involved in executing a Lambda. So it's up to you to persist or not the data. All right, any more questions? Okay, so which services can call a Lambda? Which services natively integrates with a Lambda service? So a quick way to have a look at this, let me create a empty function here just for you to see. So you have triggers, the Lambda itself, layers, and destinations. So what can call a Lambda usually are triggers. You can open this and there will be a list of services in AWS that can do it, and some other external services via Event Bridge that can also call a Lambda directly. But bear in mind one thing, a Lambda invocation is just an AWS invocation. What I mean is, if you go to the AWS CLI, so AWS Lambda, you have this invoke command. If you see it, it's going to talk about synchronous, asynchronous calls, but you just need to pass a function name and an out file to store the output. So basically, it's going to call an AWS API. So there's no secret here, right? If you are able to call Lambda via CLI, you can call it from any automation that you do. So you can do potentially anything, right? You can just call the Lambda, let the Lambda do the work for you and get the result back and keep going with your automation, your CI pipeline, or anything you need. So you can, if you need to, you can bypass the API gateway, for example. You don't need an API gateway to call a Lambda, right? That's the main takeaway. Lambda invocation is a totally separate method operation, right? But putting this aside, these ones are the services that natively integrate with Lambda. So you can just come here, say API gateway is going to call this Lambda. Then we can say it's the pet store. It's going to ask for the stage, the security you want to apply, and just edit. So these are the event sources that we have. You can read more about the documentation on these integrations here. So the Lambda invocation I just showed, the invoke method, it can happen in two different ways. It can be synchronous or asynchronous. Asynchronous invocation, as the name says, it's the invocation that waits for the response. An asynchronous one will return some partial result, like an accepted response, but the actual execution is happening behind the scenes and will complete in a later time. So for calling a Lambda synchronously, you can just invoke it directly, because that's the default way of invoking Lambdas, at least using the AWS CLI. For synchronous invocations, if you're using the CLI, you would need to pass the invocation type event. So it's going to return something like this, status code 202. If you don't know what the status code for HTTP is, you can just search for it. There's an RFC for that. But 202 is accepted. So it's telling you, I accepted this, but it's not completed yet, right? The request is good, but the work is being done yet. And depending on the AWS service that you do this integration here, so you have all of these triggers, right? Depending on your trigger here, by default, it will adopt one of these two methods. Either it's going to be synchronous or asynchronous. For example, if your trigger is S3, it's going to call your Lambda asynchronously. So let's suppose we have a S3 bucket and I upload a new file. When I do, it's going to invoke asynchronously my Lambda, and my Lambda will finish on a later time. Update in DynamoDB, new message on SQSQ, the same thing. For API gateway, by default, it's synchronous. So you do a request via API gateway, it will call Lambda. API gateway is still waiting. Lambda executes, returns, then API gateway request finishes. Right? Any questions about these two methods of invoking a Lambda? Okay. So Lambda can do stuff. It can interact with any AWS service, right? It's just code that you write and well, you can do anything. But for the AWS service interactions that we have, you need to give it permission to interact. So we have in Lambda an important concept. It's related to security. It's called execution role. Execution role is the role that Lambda assumes for its execution. So it's deny all by default. So if you go and try to create a Lambda right now, and you use the correct SDK, and you do the call to DynamoDB perfectly, following the documentation, it won't work because it will fail with some lack of permission error. So if you're calling DynamoDB, as the example I gave, you need to define it in the execution role. It's an IAM role, as you probably know by this point. You can find it in the UI. Just they changed it. Yeah, under permissions, you'll find execution role. A Lambda can only have one execution role, so you need to include all the permissions you have you need for the Lambda here in this one. If you open it, it will open IAM, so nothing new here. And here you have your permissions, right? So the only permission that this Lambda that I just created has is for creating log streams in CloudWatch and creating new log events in CloudWatch, right? In creating log groups as well. So it doesn't have permission to DynamoDB, S3, or anything else. So remember that when you're debugging and receiving permissioning problems, probably it's the execution role. Another feature related to security, which is not here, is who can invoke a Lambda? Let me check here one thing. Can you imagine all this setup using command line? Yes, you can. Yeah, Gustavo asked if you can do the setup via command line. Yeah, you surely can. There are several commands for setting this up. So who can call the Lambda, right? So again, if you are keen on Lambdas and you want to run your first function and you go there and create it, including API gateway here, it might not work depending on how you did it, right? By default, it won't work because API gateway doesn't have invoke function permission. So under permissions tab, if you scroll down, you'll find a resource-based policy. Again, it's just an IAM policy. And this will be empty, in fact. It's just here because I created via UI, and the UI, the AWS console, is doing some things behind the scenes for me. But when you're working with Terraform and CloudFormation or command line, probably you need to do it yourself. So this is going to be empty, and my API gateway won't be able to invoke my function. It will receive a denied access there. So what you need to do for every trigger that you have in a Lambda, you need to define your resource-based policy, which services can call invoke function. That's it. It's simple like that. This is the only action that you usually need to have here. and you say the service that can trigger it. That's it. Now, if you add this, your API Lambda integration will work. Right? So this one, take away. This one is about who triggers the Lambda. This one here, execution role, is about what the Lambda can do. Right? These are different steps in the flow. Yeah, I think that's it. There are some common use cases here, but for Lambdas, well, you can do a lot of things. It can be a web application backend. It can be a cron job that keeps running and do batch processing. You can use as backend for microservices, and well, anything you need some computing, and that doesn't have state mainly. So if you have an application that has some session or state, and yeah, try not to design your application to have state, first thing. Following the 12-factor apps, if you don't know it, these are good practices for design. But if you don't have state, you can consider Lambda for your processing. I think that's it. I need to move on. Any question on Lambdas? No. Let me check the chat. Okay. That's fine. So let's go to the last subject before the break. I'll try to be fast with this one. Because it's simpler to understand, but modeling it's harder, in my opinion. So this is DynamoDB. DynamoDB is a NoSQL database. Does anyone know what's a NoSQL database or what's a SQL database, relational database?
Yeah, one is relational, and the other one that you have a structure, the table is structure, and they connect each other by keys, and another one is by documents.
Yeah, yes. So yeah, that's basically it. So in a relational database, we have the structure that you said, which is the schema. And in a NoSQL database, and we have several types of NoSQL databases, right? We have graph databases, we have document databases, we can have a key value per database. Well, probably there are other types as well. But for all of these NoSQL databases, we don't define the schema prior to inserting data there. So this type of database enables you to work with unstructured data. So if you're pulling things from Facebook, from Twitter to do some analysis, for example, you don't know exactly the format, and it doesn't matter much. So you don't really want to define a schema before working with this. Like a graph database where you have a graph, right? Some nodes and the vertices between these nodes. For example, for modeling a social network. So Dennis is here, and Kayo is here, Kiko is here, then DevOps Academy students are here connected with us. You don't know how many nodes are you going to have, right? It's hard. You don't know the properties. It might start with name and surname, and it depends to have photo and other stuff. So in these cases, you want a NoSQL database. When you don't want a NoSQL database, mainly when you have an application which is query heavy, and you need to do several joins and correlations between tables or entities, then it's going to be easier to have a SQL database or a data warehouse for doing analytics. Because the NoSQL database here is more for transactional flow. So you have these analytical queries and you have the transactional ones. So if you're doing transactions, consider the NoSQL. But if you're doing heavy queries, think about the relational one. It's going to be easier to model. And for queries and reports, usually you know what you're looking for in terms of a structure, and you can define the keys and relationships and and just model it. So there's no need to make it more complex with NoSQL. So DynamoDB is a serverless service. No surprise there. It can scale up and down. It's highly available. It is fault tolerant. It can scale to 0. You can set it to work on demand. So you don't need to specify exactly how many reads and writes you're gonna do. It will just, you're gonna pay for what you use. And the performance is great, usually in a single-digit millisecond. So think that you have now a NoSQL database that scales infinitely or scales to 0 in order of a millisecond query, and you don't need to worry about servers. So that's what DynamoDB is. It's a great data store service. And in fact, it's a document database. As I mentioned before, there are several types, right? So you can store whole documents in terms of JSON formats, for example. You can store it there. It currently, it's not a long time ago, but now it supports ACID transactions. So before it was harder to keep consistency when you're doing a transaction, but now it does support it. You can write, for example, I have a batch of pets, like our API pets. But the business rule is either I write 10 pets at once, or I don't write any. I don't want to write partially, just 3, right? So this is what the ACID transactions are here, and now DynamoDB supports it. Well, encryption at rest and a number of other features, right? Main building blocks for DynamoDB. So what do you need? What do you need to care when you're working with DynamoDB, the minimum? DynamoDB has tables, items, and attributes, right? Tables, it's a set of content. It's like a table in a relational database, it's kind of, but it doesn't have a schema. Item is every row in that table. Attributes is about the information you have for every item. So as we don't define a schema, what you can infer from that is that you may have several items in the same table, but each of them with a different set of attributes. And that's a thing that's really different from relational databases. So I'm going to show you quickly. This is DynamoDB. I can create a new table. And let me just create the table for now. Then we can comment on these other fields. Yeah, it's creating the table. Yeah, that's it. It's created. So here I said this. Well, we can get to it, but the capacity mode I chose is provisioned. So I said how many writes and reads I expect to do in this database, but it doesn't have anything for now. So I'm gonna go ahead and just create an item. The only field that I have for now is ID, which is the primary key of the table. So every table needs to have at least one primary key. This primary key is ID. It needs to be unique, but you can see I can add fields of any type. Let's say I have name here. Okay, I saved it, right? So it created a new column for me. I didn't need to define it. But let's suppose I have another item here. And this one, instead of a string, will have a Boolean. Look at what it did. It created a new attribute for us. It left name blank because name was not defined for this item. And that's all right. You can have these two items in the same table side by side, just not sharing, but just using the same primary key. That's the only thing that connects these two items. You didn't need to define any kind of schema for that. And that's the real power of DynamoDB. When it comes to modeling, the first thing that comes into your mind, probably you're thinking about it, it's how do I get my relational database and I map it to DynamoDB. So we're not going to talk about it today, but DynamoDB deep dive. That's the thing you're looking for. There's a great approach for that. Yeah, this one, reInvent 2018. There's an approach called index overloading. When you actually use the same columns with different values to leverage the usage of your DynamoDB. So the only thing that you know is that this is the primary key, this is the stored key, and in fact, you have any value here. So you can put your customers, your pets, your orders, all inside of the same table. And this may sound a little bit strange at first, but it's really useful. Because if you define correctly the indexes, you're going to use just one table for everything, and you're going to optimize your provisions capacity. Right? So just getting back here, attributes, as you saw, they have data types. These are the data types. You can check it later. Boolean, list, sets, maps, numbers, number sets, null, string sets. You don't need to define it as a schema, but when you add an attribute in an item, you need to tell DynamoDB which type it is. So the type of the attribute is stored with it instead of a separate schema. That's the another main difference from relational database. You define the schema as you go, I'd say. As an example, this would be the students table, one student's item, right? It doesn't define the table, it defines just the item. So if I come here, copy and paste it here, you see you have two main visualizations here, tree or text. If text, you can say DynamoDB, JSON. There you go. ID, name, active, courses, everything that was defined in my item is now part of the table, right? So attribute types are stored along with attributes in items. So primary key, you need to have one per table, and it can be a simple one, a single attribute key called the partition key, or a composite key, as we have in relational databases that we can put together multiple keys to create a composite key, the same way in DynamoDB, but you may have just two. That's, these are the partition key and the sort key. The sort key will order your table behind the scenes by that field. So if the sort key is name, let's say, it will be ordered alphabetically. So this is about retrieval time. It can improve the performance of your queries a little bit if you take it in consideration. So we may have these two types of keys, and they can only be string, binary, or a number. The other data types, attribute types are not allowed for keys. And finally, we have indexes. So the same way as in the relational databases, we have the primary key, and we can define indexes in our tables just to keep the queries as performant as we can. You can also define indexes in DynamoDB. There are some restrictions though for that. Oh no, it's expired. That's all right. So first thing to take away from index, your partition key and sort key, if we specify it or not, because sort key is optional, it's an index. So you get it for free. So if you create a column, an attribute called ID, for example, and it is the partition key, you can query by it, and the access will be, well, the complexity of big O of 1, for example. If you need to define more indexes, so we have, I don't know, let's say suburb. We want to filter by suburb. And suburb is not a partition key, it's not a sort key. What you may have is a secondary index, or where is it? Yeah, you may have a local secondary index or a global secondary index. Now, don't get confused. The difference is simple. The first one, local secondary index, it uses the same partition key as the table you defined, but with a different sort key. And you can specify 5 only at table creation time. So if I created a table, if I did, I can see it. Okay. As I created the table without specifying LSIs, local secondary indexes, I cannot change that. I need to recreate the table. It's just at table creation time and max 5 indexes. Global secondary indexes, they can use any partition key and sort key, and you can have up to 20 GSIs that they can be created after the table creation. So people usually go and use GSIs because imagine you're working on a project, you didn't know the access patterns for that application. Then you learn that you need to implement a new feature and you really need some efficiency in that query. Probably you need to consider creating a new GSI, right? Because you cannot create a LSI anymore. So with GSIs, it's like replicating your table, but ordering it in a different way. So if your partition key was ID and name for the sort key, you're getting the same data, but this time you're ordering by suburb and timestamp, for example. It's the same data, and DynamoDB service is responsible for replicating this data and ordering it so your queries are efficient when you use the GSI. Of course, you're going to pay for it. It's almost the cost of a new table. And you can specify the amount of reads and writes you're going to have in the index and so on. Yeah, that's it. These are the two types of index you have in the DynamoDB table, putting aside the default one you have for accessing by partition key. About consistency model, the main takeaway from the section here is when you write something to a Dynamo table, that write happens straight away in a synchronous way. But when you're reading from that table, it might be consistent or not. And it's because DynamoDB is actually replicating your data in at least 3 different availability zones, I think. And by default, it tries to be as efficient as it can and returns the data to you, even if it's not the most updated one. So when you're reading a table using Dynamo, by default, you're going to fetch it in a eventually consistent way, which means it's going to return a version of the data, but doesn't guarantee this is the latest version of the data. If you need to read the latest version of the data, then you need to specify a strongly consistent read. This will make Dynamo check in at least 2 replications before returning the data to you. Why in at least 2, right? Because when you write, it will make sure it writes to at least 2 data replications before returning the OK response. So this is the way the strongly consistent reads work. Basically, you need to specify it. It will take maybe a little bit longer. So there are some cons here, some drawbacks. You may suffer a little bit in the throughput with it, higher latency, and they are not supported on GSIs, but you get the benefit of having the latest version of the data. And the last thing about DynamoDB is about the capacities that you specify for reading and writing in the table. And this is money, basically, and performance as well. So there are two main ways of setting up DynamoDB. Either you use provisions capacity and calculate how many reads and writes you're expecting to do and pay for it upfront. Well, you keep paying for the capacity, right? Because it's reserved to you. Or you can specify it's on demand, which means you can put a minimum and a maximum value, but it can float from 0 to 20,000 capacity units. The benefit is that in on-demand mode, it can scale to 0. When you specify the capacity, there is a calculation you need to do for checking the volume you have and how many capacity units you need to provide. So the rule is basically for every for every write of 4 kilobytes, it's going to be considered 1 write capacity unit, WCU. So 1 WCU, 1 kilobyte per second. When you're reading the table, we know that we can read in 2 different ways, eventually consistent and strongly consistent. If you're reading in an eventually consistent way, you can do 2 eventual consistent reads per second for an item of up to 4 kilobyte size. Or you can do 1 strongly consistent read per second for an item up to 4 kilobyte size. So, you know, it's a lot of numbers. I don't intend for you to have this in mind right now. But if I come to you with some requirements saying I have 10,000 reads in my database and I'm reading table X and I'm fetching the whole item, you're going to be able to calculate the item size per time, per second, and achieve a number of RCUs that you need to set up for that DynamoDB table. That's the idea. You can do this capacity calculation and set the proper capacity for a table. I think that's it. Do you have any question about DynamoDB? No? Ready for the break? Yeah. Okay, so let's do a quick break. 10 minutes, 7:30. We come back.
Okay.
Yep.
Yeah.
So 7:30.
Yep.
Nice, guys. Thank you.